Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone. Welcome to Bohdi Park NEET and J Academy. So today we are going to discuss 10 MCQs on vectors. Okay. So to subscribe for the app, you can find the details in the description. Okay. So let's start with the first question. So look at this first question. Which of the following statement is true? So first option, scalar quantity is the one that is conserved in a process. Conserved means remains same. So generally in physics, we consider mechanical energy conservation, that is sum of kinetic energy and potential energy. Then angular momentum conservation, linear momentum conservation. So these are vector quantities. So angular momentum is vector quantity, it can be conserved. Linear momentum is a vector quantity, it can be conserved. So only for a scalar quantity, it is saying scalar quantity is the one that is conserved. So basically vector quantity can also be conserved. And in charges also we study charge is conserved. Charge can neither be created nor be destroyed, but one charge can be transferred, correct? So this is not proper definition of scalar quantity. Scalar quantity can never be negative, so that is false. Okay, charge, electric charge is a scalar quantity. Charge can be negative and charge can be positive. Charge can be positive or negative, and there is a work done also. Work done is a scalar quantity. Work done can be positive or negative. Electric flux, magnetic flux, flux can be positive or negative. These all are scalar quantities. Okay, so scalar quantity can be positive, can be negative. So this second option also not fitting over here. So scalar quantity is the one that does not vary from one point to another point in space. So this is also false, because scalar quantity can change, can vary from one point to another. Like for example, potential. So gravitational potential at different point it is different. As we know, suppose this is the earth, the mass is m, so r distance, gravitational potential is minus gm by r. So at different distance the potential is different. So third option is not correct. A scalar quantity has same value for observers with different orientations of axis. So for example, we have a concept of moment of inertia. So when the axis changes, so moment of inertia changes. Okay, and they are saying for different observers. Okay, sorry, they are saying same value for observer with different orientation of axis. Means if axis is different, then observer is also changes. So the value of quantity is same. So the best option among these four is fourth option. Okay. Okay, so next second question. Question number 2. Two vectors are given, A vector and B vector. Vector having same magnitude as B and parallel to A. So the magnitude is same as B. So what is the magnitude of B? B vector magnitude is square root of 7 square plus 24 square. And parallel to A, So that means direction is same as A. So the unit vector is A cap. So the direction of A cap, that is A vector, is A vector by magnitude. So this is 3i plus 4j, and the magnitude of A is a square root of 3 square plus 4 square. So 3i plus 4j by 5. Okay, so this is the direction of A vector. Now we have to find vector having same magnitude of B but direction of A. So suppose the vector is C vector. So C vector, the magnitude is B but direction A. So this will be square root of 49 plus 24 square, so which is 576. Then A cap is 3i plus 4j by 5. So let's solve this. So this will be 625, then 3i plus 4j by 5. So we can say this is square root of 625 is 25. So 25 by 5, 5. So 5 into 3i plus 4j. So that is 15i plus 20j. This is the answer. Done. Now next question. Now look at this third question. In third question, 6 vectors, A vector, B vector, C vector, D vector, E vector, F vector. So there are 6 vectors. So let me draw these 6 vectors once again. So this is A vector, this is B vector, C vector, D vector, E vector, F vector. So these are the 6 vectors. So we have to select which is correct. Like B vector plus C vector is equal to F vector, or D plus C is equal to F, or A plus E is equal to F, or B plus E is equal to F. So we have to use triangle law. So suppose, let's check first B plus C. Let's check B plus C. So B plus C. So on the head of B, you put tail of C. That is the C. So this is B vector, this is C vector. So resultant is this. Okay, third vector with opposite order is the resultant. Okay, so this vector is B vector plus C vector, this third vector, and this third vector is looking like F vector. If you observe, the direction is same. B vector plus C vector and F vector, they have same direction. So this is correct. B vector plus C vector is equal to F vector. Now let's check D plus C is equal to F. So D, this is a D vector. Now if we add the C vector to this is C vector. So tail of C will come on head of D. So this will be D vector plus C vector. Now they are saying D plus C is same as F. So this is wrong, because this is D plus C and this is F. So they have different directions. So they are not equal. So second option is wrong. Now A plus E is equal to F. So this is A plus E, this is E. So A vector plus E vector. So resultant will be same direction. This will be the resultant. A vector plus E vector. So A plus E, they are saying F. So no, it is wrong, because direction of A plus E and direction of F are different. So third option also wrong. Now B plus E is equal to F. So B, this is B, and this is E, and that is equal to F. So B plus E is equal to F. So this is also correct. This is also correct. So fourth option is also correct. Okay, done. Now next question. Now look at this fourth question. Two vectors are given, A vector and B vector. We have to find angle between A vector and B vector. So we will use the dot product formula. A vector dot B vector is equal to AB cos theta. So A dot B, we will use A1 A2 plus B1 B2 plus C1 C2, and that is equal to AB cos theta. So let's find A1 A2 plus B1 B2 plus C1 C2. So A1 A2, so 4 into 3 plus B1 B2, 4 into 1. Then C1 C2 minus 4 into 4. Let's calculate. So 12 plus 4 minus 16. So this is coming 0. So AB cos theta is equal to 0. So cos theta is equal to 0. Cos theta is 0. So angle theta is equal to pi by 2 or 90 degree, correct? So perpendicular vectors. So second option, done. Now next question. Now next question, fifth question, we have position vector given. This is the position vector. Position vector of a particle r vector as a function of time. As a function of time. You see, this is r vector, and you see 4 sine 2 pi t I cap plus 4 cos 2 pi t j cap. Okay. So t is in seconds, I and j denote unit vectors along x-axis and y-axis. So that is the direction along x-axis and y-axis, which is wrong. You have to select wrong statement. Okay, so we have to find acceleration, then magnitude of acceleration, magnitude of velocity, path followed by the particle. We have to find out. So let's discuss. So differentiate this r vector, we will get v vector, okay, dr vector by dt. So this is the differentiation with respect to time. We'll get velocity vector. So let's discuss this. So suppose y is equal to a sine bx. So dy by dx is equal to ab cos bx. Okay, this is the formula in differentiation. And suppose y is equal to a cos bx. So dy by dx is equal to minus ab sin bx. Okay, so these are the formula. Let's apply these two formula. So over here we have 4 sin 2 pi t's. This will become 4 into 2 pi into cos 2 pi t I cap. Then over here it will be minus 4 into 2 sin 2 pi t j cap. So that this is equal to 8 pi cos 2 pi t I minus 8 pi is also there. Okay, minus 8 pi sin 2 pi t j cap. Okay, so this is velocity vector. Now let's find acceleration vector. So acceleration vector is differentiation of velocity. So this will be minus 8 pi into 2 pi. So minus 16 pi square sin 2 pi t I cap. Then minus 8 pi into 2 pi. So 16 pi square sin 2 pi t into j cap. Okay, so this is the acceleration. If you notice over here, this is sin 2 pi t I cap coming, and Okay, here cos will be there. Okay, yeah, here cos 2 pi t is there, cos. So we can say if you take minus 4 pi square common, so a vector, if you take minus 4 pi square common, so we have here 4 sin 2 pi t I cap plus 4 cos 2 pi t j cap. So a vector is equal to minus 4 pi square into, now if you see this is r vector. So acceleration is along minus r vector. So direction of acceleration is along minus r vector. So it is true. So first option is correct. Now magnitude of acceleration is v square by r, where v is the velocity. So what is the magnitude of v? We can find magnitude of v square root of, this is 8 pi, so 64 pi square cos square 2 pi t plus again 8 pi minus 8 pi, so square will be 64 pi square sin square 2 pi t. So this is 8 pi into 1. Okay, cos square theta plus sin square theta is equal to 1. So this is 8 pi. Magnitude of velocity is 8 pi, and magnitude of acceleration is equal to 4 pi square into magnitude of r, and magnitude of r is square root of 4 square into sin square 2 pi t plus cos square 2 pi t. So this is 4. So magnitude of r is 4. So magnitude of acceleration is 16 pi square. Now let's find out what is v square by r. So v square by r is equal to 64 pi square by r. So the magnitude of r is 4. So 16 pi square. So this is matching. So magnitude of acceleration is the same as v square by r. So this is also correct. Second option is also correct. And the magnitude of velocity is 8 meter per second. So time should be given, then only we can find magnitude. Wait. Without finding time also we can find magnitude, because cos square theta plus sin square theta is 1. So this is the magnitude 8 pi. Magnitude of velocity is 8 pi. We already got 8 pi. So this is wrong. Magnitude of velocity is 8 pi, not 8. Path of particle is circle. So yes, correct. It is circular path. How to check it is circular path? If we have r vector perpendicular to v vector, then it is circular path, because the position vector and velocity vector are perpendicular. So suppose particle is here, so this is the position vector and this is the velocity vector. So velocity is tangential and the position vector is along radius. So find out the dot product. If we can prove that the dot product of r vector and v vector is 0, then we can prove that it is a circular path. Okay, so if we find the dot product of a v vector and r vector, so over here this is v vector and this is r vector. So again a1 a2 plus b1 b2. So find out. So when you find a1 a2, this is 4 into 8 pi. 4 into 8 pi into sin theta into cos theta. sin theta into cos theta, okay, plus 4 into minus 8 pi into sin theta into cos theta. So this is 0. So dot product is 0. So that is r vector and velocity vector are perpendicular. So it is a circular path. So fourth option also correct. So the wrong option is third option. Now next question. Now sixth question. Length of second hand in watch is 1 centimeter. What is the change in velocity of its tip in 15 seconds? So suppose this is the watch. We have 12 over here. This is 12. This is 3, 6, 9. The second hand, initially second hand is at 12. And after 15 seconds, it will be at 3. So this is the initial position and this is the final position. Change in velocity. So initial velocity is v I cap and final velocity is minus v j cap. So change in velocity is equal to final velocity minus initial velocity. So minus vj minus vi. Now we have to find the magnitude of change in velocity. So change in velocity magnitude is equal to v root 2 using this formula, square root of v square plus v square. So square root of 2v square. So v root 2. Now what is the v? V is equal to r omega. So r means the radius. So radius means the length. Length of this second hand is 1 centimeter. And omega, the value of omega is 1 round per minute. The second hand covers 1 round in 1 minute or 60 seconds. So this is 10 raised to minus 2. Okay, we have answer in centimeter only. So let's keep it in centimeter. So 1 centimeter by 60, and round means you have to convert this in angle. So this will be 2 pi. So pi by 30 centimeter per second. So v root 2 means it will be pi by 30 into root 2 centimeter per second. So fourth option. Now next question. In this next question, it is based on relative motion. Okay, so we have boat moving with velocity 3i plus 4j with respect to ground. So VB vector is equal to 3i plus 4j. Water is moving with velocity minus 3i minus 4j. So velocity of water, or we can say river, velocity of river minus 3i minus 4j. Relative velocity of boat with respect to river or water. So velocity of boat relative to river, boat relative to river, so that is equal to VB minus VR. So now let's find the difference. So VB vector is equal to 3i plus 4j minus VR vector minus 3i minus 4j. So this is 3i plus 4j plus 3i plus 4j. So 6i plus 8j. 6i plus 8j. Third option. Okay. Finish. Now next question. Question number 8. What is the value of linear velocity if omega vector is given 3i minus 4j plus k and position vector is given 5i minus 6j plus 6k? So we have a formula for linear velocity, direct formula over here. So direct formula v vector is equal to omega vector cross r vector. So we will use the determinant method. So this is I, j, k. This is the first row, and second row will be that of omega, which is 3 minus 4, 1, and third row will be that of r vector, which is 5 minus 6 plus 6. Now we will do I cap into minus 4 into 6 minus 6 into 1. Then minus j cap 3 into minus 6 minus 3 into plus 6, so plus 18 minus 5 into 1, so plus 18 minus 5. Then plus k cap 3 into minus 6 minus 18 minus 5 into minus 4 minus 20. So this is I cap into minus 24 plus 6, then minus j into 18 minus 5, so 13, then plus k minus 18 plus 20, so that is 2, so minus 18i minus 13j plus 2k. So fourth option done. Now next question. In the ninth question, we have been given a vector cross b vector amplitude is equal to root 3 times a dot b magnitude. So we know that the magnitude of a cross b is AB sine theta, and this is root 3 times of, according to question, this is a dot b, which is AB cos theta. So AB cancel. So tan theta is equal to root 3. Now we have to find the value of a vector plus b vector amplitude or magnitude. So that is square root of a square plus b square plus 2ab cos theta. Now tan theta is root 3, so theta is 60 degree. So cos 60 is 1 by 2. So the vector a vector plus b vector magnitude is equal to square root a square plus b square plus 2ab into 1 by 2. This 2 to cancel, so we'll get square root of a square plus b square plus ab. So this is the fourth option. Now next question. Tenth question. With respect to rectangular Cartesian coordinate system, three vectors are expressed: a vector, b vector, and c vector. The unit vector along direction of some of these vectors. Unit vector is equal to vector by magnitude. When we divide vector by its own magnitude, we get unit vector. Now the vector is sum sum of these vectors, so add, so a vector plus b vector plus c vector, so 4i minus j minus 3i plus 2j minus k, so I and I together, so 4 minus 3 1, so I, then minus j plus 2j, again plus j, then minus k. So this is the a vector plus b vector plus c vector. Now what is the magnitude of this vector, a vector plus b vector plus c vector? So magnitude is square root of a square plus b square plus c square. So 1 square plus 1 square plus 1 square, so this will be root 3. So the unit vector of this vector is vector by magnitude. So I plus j minus k divided by root 3 or 1 by root 3 outside, then I plus j minus k. I plus j minus k into 1 by root 3. Okay, first option. Okay, done. Okay, thank you.